is example 2 of lesson 2.5, which is called Simplifying Algebraic Expressions. We're actually going to get to the simplifying this time. Last time we talked about what a term was. You might hear the phrase combining like terms or simplify like terms. And we talked about how like terms have the same variable, the same letter. Not the same coefficient, the same number in front of them, the same letter. So we are going to spend some time combining like terms. How do we combine like terms, you ask? Good question. Well, let's go into that. So here we have an expression, 4x plus 3x plus 5x. And we know that this here, 4x, I'll click on that, is the same as 4 times x, right? 4 times x. Or we could write this as x plus x plus x plus x. We have 4 x's. Similarly, put parentheses around that. Similarly, this 3x could be written as 3 times x, and I'm going to put, I should have put that farther away, I'm sorry. And this 5 could be written as 5 times x. I'm going to rewrite that 3 up on top, because right now it looks like I'm multiplying them all together. So 3 times, oops, not times with an x, my goodness, times x, which could be written as x plus x plus x, because as we know, multiplication is just repeated addition. 2 times 4 is the same as 4 plus 4, or 2 plus 2 plus 2 plus 2. This is not exponents. Do not confuse this with exponents. Exponents is multiplying, not adding. And the 5x can be written as, my goodness, x plus x plus x plus x. So we have a lot of x's here. All right, this is the 3x, the 4x, I mean, bam. This is the 3x, bam, and this is the 5x. So when I'm adding all of these together, because x, if I'm using it multiple times in the same expression, will have the same value. If I say x equals 6, it's going to be 6 for all 3 of them, right? So what I can do here is just count up my total x's, which is going to be 4 plus 3 plus 5, which is going to be 12. So I have 12 total x's, which means that my answer, I can rewrite this expression into an equivalent expression, meaning an expression that is exactly the same as this one. I can rewrite this as 12x because I have 12 x's total. Let's do that again. Here's another expression. 8y plus 6 plus 3 plus 4y plus 1. So here we have 2 different kinds of terms. Remember, a term is any part of an expression. All of these are terms. However, some of these terms are constants and some of them are variables. So we have to discover which ones are like terms. Well, this one has a y and this one has a y. So these are like terms. And 6, 3, and 1 are all constants, so they are also all like terms. So let's look. We are all adding across here. It's 8y plus 6 plus 3 plus 4y plus 1. So we're not getting rid of anything just yet. We're just adding. So here I have 8 y's, a total of 8 y's, and over here I have a total of 4 y's. So if I combine those y's, 8 plus 4, I'm going to get 12 y's again. Complete coincidence there. 12 y's. Now, let's combine our constants. We have 6 and 3 and 1. 3 and 1 is 4, plus 6 is 10. So, our total number of constants is 10. These 2 expressions, this one here and this one here, are equal to the same thing. If I plugged in y equals 2 into this one, it would be exactly the same thing as if I plugged y equals 2 into this one. These are equivalent expressions. They equal the same amount. Let's do another one. Okay, this one's a little bit trickier. Why? Well, for 2 reasons. One, I have two different variables. I've got m and I have p. The other tricky thing about this one is that we have right here in the middle a couple of minus signs, which I'm going to erase the red I put under them because it makes it look like equal signs. So we've got minus and plus this time. So let's first identify our like terms. Looking at the variables, we have m and p. Let's underline all the m's with red, okay, and the p's with yellow. 3p and 10p. Oops, I changed my marker size. I don't want that. 3p and 10p. Now, this one's a little bit different. Like before, we have a number of variables. We have 9 m's here and 4 m's here, but here we have something else. Notice that this is minus 2 m's. So here I'm taking away 2 m's. So I'm going to have 9 m's minus 2 m's plus 4 m's here. So if I wrote all of these out, these 2 m's would be going away. So I can do 9 minus 2 is 7, plus 4 is 11. So all told, we have 11 total m's. Now let's look at our p's. Here we have 10 p's, 10 p's. And here we're taking away 3 of those p's. So if I wrote this out, p plus p plus p, oops, that would be multiplying p, plus p, etc. And then minus p. Every time I minus p, it would cancel out one of the plus p's. So I'm just going to subtract 3 from 10, and I'm going to have equals 7 p's. And that's my total p's. Now, I'm not done yet, because I haven't rewritten my expression. It was 9 plus 10, so both of these are positive numbers. So we're going to have, we're going to have 11m plus 7p. 11m plus 7p is an equivalent expression to this big one up here. These two will equal the same. If I have my m equals 4 and my p equals 7, I can plug them in here, and it will be exactly the same thing as if I plug them into here. I have one more for us. All right. Let's first identify our terms. Identify your terms first. We've got D and D, and D and D. And we have constants, 12 and minus 12. Okay. If you're familiar with negative numbers, you can think of them as negatives, but you don't have to for now. So let's go ahead and break this out. We started with 4D, and then 4D, by the way, not 40, 4 times D, and then we added one more D. So we're going to have a total of 5D. And we started with 12, but then we got rid of 12. So what happens to our 12? Well, they kind of cancel each other out. So we're left with just 5D. These two things are equivalent. They are the same. And that is simplifying algebraic expressions. Combine like terms. First, you look at the terms, what letters do I have in common? And then I add or subtract as I need to.